Hey guys, and welcome back to Digital Learning. Today we're going to look at how we measure an angle. There's one thing you generally would need for measuring angles, and that is a protractor. Now, due to the circumstances, some people have them, some people don't. So we're going to use digital protractors this week to do our measuring of angles. So that's the one tool you need to do this. So let's get started. Okay, the first thing I always tell my students to do is when they look at their angle before they place their protractor, is to look at it and decide, is this an acute angle? Is this an obtuse angle? Or is this a right angle? If we look at the angle before we put the protractor on it and we say, oh, well, it's an acute angle, then we know the measurement should be less than 90 degrees. But if we look at the angle and we say, well, that looks like a right angle, then it has to measure up exactly with 90 degrees. Or if we look at the angle and we decide, that's a really wide angle, I think this is going to be obtuse, then we know our angle measurement should be more than 90 degrees. So if I take a look at the angle that's already on my page, and this is angle LMN. If I look at angle LNM that's already up there, I can look at that angle and go, that's a pretty small angle, and I think it's going to be an acute angle. So I know that when I use my protractor and I start taking the measurement, then I think at this point, from what I already know about the different types of angles, this particular angle seems to be acute, therefore it should be less than 90 degrees when I get my measurement. So to get started, the first thing you do is take the vertex, remember, which is where the two rays meet. So here's a ray, and here's a ray. They meet right here at point M. So I take that vertex point, and I put it right on that circle that's in the middle of my protractor. Sometimes you have crosshairs there on different protractors, and it may look like this. Sometimes you just have an open circle like that right there. And sometimes there's actually like a crosshair there. This particular protractor simply has the circle. So, after taking a look at my angle, thinking it's acute, I've lined one ray, one arm up flat on my zero, which is right there. One of my my arms crosses the line at zero. Then I look and see where my other arm, remember these are the arms, what number they cross at. Well, this particular arm of this angle crosses my protractor at 120 or 60. Well, looking at this angle, we know that this is an acute angle. It is not obtuse. It is not a big, wide angle. So therefore, I know the degrees of angle L, M, and N equals 60 degrees. And that's it. That's how you measure an angle. So we'll try another one out. We'll go to our next page. I already have the protractor drawn. I'm going to make this protractor a little, well, I say I was going to make it a little bigger. Yeah, there we go. Okay. All right, I got to draw us an angle here. I'll choose the darker color. All right, so let's look at this angle. I'm going to try to get this drawn well the first time. Okay, so there's my one arm crossing over zero. And then I have my other arm crossing over up here. Now, when I look at this angle, I notice this is a wide angle. So therefore, I think it is an obtuse angle. Well, we said an obtuse angle is greater than 90 degrees. So therefore, when I measure this angle, it needs to be greater than 90 degrees. So I look at, we have one arm over the 0, crossing the 0. We have our vertex. Oh, we forgot to name this one. We'll just name this one A, B, C. Angle ABC. So we see that our vertex is lined up, and the arm A is wide open from C. So we said it was obtuse, therefore we know it's greater than 90. So arm A falls across our protractor right here at the 120 degree mark. So we would say angle ABC equals 120 degrees. Okay, so let's do another one. Okay, so what about if you see this angle? We'll name it. We'll name this angle H, I, and J. Okay, so this is angle H, I, and J. We need to find its measurement. By looking at this measurement, I think this is probably a right angle. So therefore, from our notes from Monday, I know that a right angle equals 90 degrees. So I'm going to have to check that. So I line my vertex, which is I, right here at my midpoint. And then I have one of my arms, arm J, lined up at 0 degrees. And then I see where my other line falls. And by looking at arm H, which is this arm right here, I notice it falls right across the 90 degree mark. So I know angle H, I, J equals 90 degrees. So therefore, yes, it is a right angle. Okay, what about if you have an angle that looks like this? When I look at this, and if I just look at the numbers, I go, oh, well, it's 0, it's nothing. But remember, an angle is two rays that meet at an endpoint. So here's our endpoint. This is actually considered to be what we called, if you remember from Monday, a straight angle. And straight angles their measurement is 180 degrees. So this is actually what we would consider to be a straight angle. Okay, moving on to the next one. And this is just for practice at this point. I think you guys probably all are catching on very well. Okay, let's see. How about if we have an angle that... drop my pen. If we have an angle that looks maybe like this. We'll name this angle E, F, and G. So this is angle EF and G, EFG. Now, we notice we've lined up our vertex right here at our midpoint, our vertex F. And we have our arm of G lined up across our 0 like we're supposed to. And we need to see what our measurement comes out to be. So we take a look up here and we look at where it falls across. I also remember I have to look at this angle before I do anything and go, okay, is it acute? Do I think this is an obtuse? Or do I think it's a right angle? And just by taking a quick look at this, I think it is acute. So I'm going to measure it to check. So I look at my protractor and I look, well, there's the 30 and there's 40 and it's right in between the two. Now, I didn't do 140 and 150 because we said this is an acute angle. So it wouldn't be those two because an acute angle is less than 90. So it's right between 30 and 40. Well, there's a little line right there notating the half mark under this arm. So that tells me that this angle measures at about 35 degrees. So I will write that as angle E, F, and G equals 35 degrees. Okay, on to our next. Now, sometimes your angles are not always facing the right, meaning when they're laid out on a paper and you're using a true protractor, they don't always open up this way. Sometimes you will see an angle and it will be opening up the other way. So you may see an angle that looks like this. Notice that the opening of the angle, all this right here, is opening up this way. So I have to start it a little bit different. The thing is, I still do the exact same thing I did when it was facing the other direction. I line up one of the arms on 0. I make sure my vertex is right here at my midpoint. And then I measure after I decide what I think this angle will be. By looking at this angle, it's not a right angle. It's close to it, but it's not. So that tells me it's most likely an acute angle, which means it's less than 90 degrees. I notice, I would need to name it, I'm sorry. We'll name it Q, R, and S. I notice that the ray S crosses over right between 70 and 80. So I would say angle Q, R, and S equals about 75 degrees. It is acute. It goes right along with it. Okay. And that's it, guys. That is how you measure an angle. So today's practice is going to be all about measuring angles. Some of you who have protractors will be able to practice this with written angles, and some of you who don't will be using actual protractors the other way. But some of you who don't have an actual protractor will be using a digital protractor on today's work. So we will talk again soon, and until next time, have a great day. Thanks, guys. Bye.